Right, so today we'll be talking about conditional probability. We have already discussed the basics of probability, all that we studied in O levels. So today we'll talk about conditional probability. Okay. Now, conditional probability is also a probability, but we'll be having a condition with it. So the formula is going to be a bit different. Okay. So whenever the question is about conditional probability, we would be talking about two events. So there would be event A, that would be the first one. And then event B, and this is going to be the second one. Okay. Now the wordings could be that find the probability of A, that is the first event, given that B has already happened. Okay, this is the typical wording of a conditional probability question. Although it is not necessary that the examiner is writing down this way in your paper as well, because we will talk about an example where we do not have such wordings, but still that question is to be solved using the formula of conditional probability. Okay, but I'll write down the wordings which we are using. So it could be that the question is something of this type: find the probability of something where you're writing it down as A, given that B has already happened. Okay, now this could be anything. For example, the question could be of this type: find the probability that Ali is going on school given that it was a sunny day, stuff like that. Okay, so we'll be talking about these examples shortly, but first we need to define the formula. So for such a question, the format is probability of A given that B has already happened. Okay, so this is basically the probability which we are looking for, but it's not only probability of A. We have a condition that B has happened already. Okay, so these are two things. Now, how do we find it? We have a fixed formula for conditional probability. This is equal to probability of A and B divided by probability of B only. Please be very, very careful about A and B. Okay. So it says find the probability of A given that B has already happened. So we will be talking about the event A as the event whose probability we are basically finding, and the condition is B. Okay. Now I assume that this formula is clear. If you guys have understood the formula, we can talk about the question, and then we'll talk about a past paper question. Okay. Now this is the formula. I'll write down an example and then let's see. Okay. So in the last class, we discussed a tree diagram. I'll make the tree diagram first, and then I will talk about the example. So most probably these questions are going to come with the tree diagram part, but it depends. Okay, so so we had two scenarios. If it was a rainy day, if it was a sunny day. We discussed this tree diagram earlier as well, so I'm just making it directly. Okay, if it is a rainy day, the probability that he would be going by walk was 1 by 4, by bus 2 by 7, and then by cycle you guys would be finding it out, and then by bus it was 2 by 7, and then by cycle you need to tell me. Okay, so this is not the question. I just wanted to revise the previous contents. This is example number 1. Okay, so we will talk about the conditional probability question using this tree diagram. Before that, I would want you guys to calculate the probability of this part and of this part. Just complete this tree diagram, okay? We know that sum of probabilities coming out from one branch is basically 1. So now you can easily find it out. 1 minus 1 by 4 plus 2 by 7 is going to give you 4 by 7. So this is going to be 4 by 7. And yes, Munjay, can you tell me the other one? This one?
5 over 7.
Very good. 5 over 7. Excellent. Okay. Now this was the just a quick revision. Okay. Now let's talk about the question. So the wordings are something of this type. Given that Ali went to school on cycle, find the probability that it was a sunny day. Now do not rush at all, okay? For mechanics and statistics 1, this is I'm telling you guys again and again, understanding the question is equally important. In pure maths, you can start your working, that is okay. But for this, you need to spend good enough time for understanding the scenario, and solving would not take too much time, okay? Now you need to find the probability that it was a sunny day given that Ali went to school on cycle. So A is basically sunny day and B is cycle. All right. Okay. That is the question. So let's see how to do it. Okay. Now we know for finding conditional probability, it is A given that B, it is equal to probability of A and B divided by probability of B only. Okay. Now A and B, sunny and cycle. So I would be referring to the second branch, sunny and cycle. So I have two branches basically. So we know we multiply for such cases, and we also know from the word and we are always multiplying. So it would be 2 by 9 multiplied by 5 by 7 divided by. How do I find the probability of B? Like, what is the probability that he is going by cycle? So I've told you earlier as well, please do not say 4 by 7 plus 5 by 7. No, it is not 4 by 7 plus 5 by 7. You need to take in account these as well. Okay. So he's either going on a rainy day. So it could be 7 by 9 multiplied by 4 by 7 plus. It could be that he's going on a sunny day. So that is again 2 by 9 into 5 by 7. So you need to simplify this, just simplify this and tell me the answers, all of you. The numerator would become 10 divided by 63, and for the denominator, just do that quickly, please. I'll be waiting. So the final answer is going to be 5 by 19, and that is the correct answer. This should be 5 by 19, and it is 5 by 19. This is going to be the answer. All right, so here your answer is correct, but you need to think about, like, it is just the first part, right? You need to divide it by this as well, and then it would be perfectly okay. All right. Yes, Ishal, and then Mundya, Sahib, and the new student. Is that okay? Any questions?
No, ma'am.
No.
Okay. And what about you, Mundya?
I'm okay, thank you.
All right. Ishal, is that okay? I'll be shifting to past paper question in a bit, so I just want to have this confirmation if it is okay or not. All right. Okay. So I assume it is okay. I'll stop sharing this. I'll share the PDF for past paper questions. Okay. Let's talk about two past paper questions. So this is the first one. It says, Maria chooses toast for her breakfast with probability 0.85. If she does not choose toast, then she has a bread roll. If she chooses toast, then the probability that she will have jam on it is 0.8. If she has a bread roll, then the probability that she will have jam on it is 0.4. Yeah, apparently it looks very, very complicated, but it is not. After the first part, it would become very easy. Draw a fully labeled tree diagram. Okay. Now this tree diagram is going to make things very, very easy for us. So either she is having toasted bread or simple bread. Okay. So yeah, sorry, toast or bread roll. These are the two things. So either she is going to have toast, and the second one is bread roll. Okay. What is the probability that she's having toast? It's there, 0.85.
Nice.
And the probability that she would be having a bread roll is something which we can find out automatically. It is not given, okay? So we know
0.15.
very well done. So 1 minus 0.85, and that is going to be 0.15. Excellent, okay? Now, let's see. If she chooses toast, then the probability that she will have jam on it is 0.8. Now, for jam, it is 0.8. And if she has bread roll, then the probability that she will have jam on it is 0.4. Okay. So this is 0.4. Okay. But the fact that there's nothing else, like we do not have butter, Nutella, or any other thing. So this means that if this is jam, it would be no jam or without jam, stuff like that. Okay. Because the sum should be 1. So this would be 0.2, and for this one, this was for jam, and then for no jam, it is going to be 0.6. Okay, and that is it. You got your 2 marks. Okay. Once you have this probability diagram in front of you, now the interpretation of the given information is very, very easy. Otherwise it was very difficult. Even I was not able to understand what exactly they were trying to tell. Okay, but once you have everything in front of you, things get very easy. Okay, let's talk about the second part. I was interested in this one. Given that Maria did not have jam for breakfast, find the probability that she had toast. You need to find this probability, and given that is that she did not have jam. Okay. Now again, this is a question. of conditional probability. So first of all, let's write down A. A is for toast and B would be for no jam or not jam or whatever you want to write down. Okay. Okay. Now, if I read the question again, it should be find the probability that she had toast given that Maria did not have jam for breakfast. So probability of toast given that no jam. This is what we need to calculate, and we are not interested in the statements. We are only interested in the tree diagram. So this is going to be equal to probability of toast and no jam divided by the probability of B only, that is no jam. All right. Now for the numerator, can you guys please simplify this question, simplify this and tell me the answers? I'll wait. For jam and for toast and no jam, we will be talking about this to this. Okay, this is what we have. Okay, so this is going to be 0.85 multiplied by 0.2. All right, divided by for no jam. So for no jam, I told you earlier as well, we are not going to add 0.2 and 0.6. We need to take in account toast and bread roll. So it would be 0.85 into 0.2 plus 0.15 into 0.6. And now we'll simplify this. So the numerator would be 0.17 divided by 0.26, and this is going to give us 17/26. Yeah, okay, I got one answer as 1.7. So basically, when we talk about probabilities, I know this happened because of some minor error, but the probability can never be greater than 1. Okay, and then Zahib, just check the denominator. 0.85 into 0.2 plus 0.15 into 0.6, and that is 0.26. Okay, so just check your workings again. This should be the answer. I'll wait for a minute and I'll zoom out just so you guys can understand this nicely, and once done, I'll talk about the next part. Yes, any doubts in this one? Any misunderstanding, anything that you were not able to understand? Yes, very good, Zahib. Excellent. That is the correct answer. All right. Okay, perfect. Okay, so Munja, any doubts? Yes, Munja, did you understand the question?
Yeah, 0.7 or 0.65.
Yeah, okay. So I would advise you not to go for the decimal number, because you know the answer is 0.6538461538. Okay. So just
Yeah.
try going with the fraction until and unless if the examiner is telling you to find the answer.
Okay. All right.
Yes, I do understand that here the decimal numbers are given, but then this is what he's giving. Okay, in our case, if we start writing down the decimal number, that would give us the wrong answer because we would be rounding it off and that would not serve the purpose. Okay, right, so this was the first question. Let's talk about another one. Okay, so this is the sixth question, and it says Box A contains 7 red balls and 1 blue ball. Box B contains 9 red balls and 5 blue balls. A ball is chosen at random from box A and placed in box B. A ball is then chosen at random from box B. The tree diagram below shows the possibilities for the colors of the balls chosen. Complete the tree diagram. I'll stay quiet for a minute, just understand the question and then we'll solve it together. Okay, now we can try doing it. Okay, so it says for box A, what is the probability of getting a red ball? So we have 7 red and 1 blue ball, that is it. So total is 8. For red, it would be 7 by 8. Okay, and then for blue, it would be 1 by 8. Okay, now for the second box, box B contains 9 red and 5 blue balls, so total of 14. A ball is chosen from box A and placed in box B. So this 14 would become plus 1, 15. So if it was a red ball, we'll take it out and put it in the box B. Box B initially had 14 balls only, and now it would have 15 once I've placed a red ball in it. And initially we had 9 red balls, but if in box A I got red, and since I have placed that red ball in the box B, so now it would be 10 by 15. And for the blue, can anyone tell me what would be the probability for blue?
5 by 15.
Very good. It would be 5 by 15. Yes, very good, Ashal. Okay. And then for the second one, for this red one, so again, the total is going to be 15. But now, since we had 9 balls initially, and now we have placed a blue ball in the box B, so it would be 9 by 15, and this would be 6 by 15. All right. So you can just understand this. Meanwhile, I'll just get rid of all this. Okay. Now this was a 3-mark question, and trust me, once we have this tree diagram in front of us, it would be very easy to understand or interpret everything. So I'll zoom out and let's talk about the next part. Here it is. Okay. Now it says, find the probability that the 2 balls chosen are not the same color. Okay, not the same color. All right, so here it is. Not the same color means if I am picking up a ball from box A, it is red, and then in box B, I'm taking out blue, and then if I was just taking out blue initially, so I take out red. So this would be the branch I'll be following, and then this one. So 7 by 8 multiplied by 5 by 15. I've told you earlier as well, when we are talking about the same branch, so we multiply, and for 2 different branches, we add. 1 by 8 multiplied by 9 by 15. So this is going to be the working and everything. So your final answer after simplification would be 11 by 30. I'll wait for a few seconds. Please try understanding. The question was about finding the probability of not same. Okay. So for not same, it could be red blue or blue red. You could have done red red, blue blue, and 1 minus that probability, but this is not that difficult, so I just did directly. This was easier in this case. Okay. So it would be 11 by 30. All right. So this is the answer for the second part, 11 by 30. Okay, and let's talk about this. Now we need to talk about find the probability that the ball chosen from box A is blue, given that the ball chosen from box B is blue. All right, okay. So event A is that it is blue, and then event B is also that it is blue. Okay. So basically, we are trying to find out the probability that from box A we got blue, given that the ball chosen from box B was also blue. This is B. Now, once we have understood the scenario, once we have written this, we can easily write this down. Probability that from A it is blue and from B it is also blue, and we are to divide this by, let me write it down properly. So we'll divide it by probability of getting a blue ball from box B. Okay. Now, for the first one, it's A and B and it's blue and blue. So let's scroll up and see. Okay. A and B, blue and blue. So I'll be talking about this part. So this would be 1 by 8 into 6 by 15 because I'm staying in the same branch. So 1 by 8 into 6 by 15. And now I need to divide it by this probability of getting a blue ball from box B. Okay. This is box B, this is blue, and this is blue. So I've been telling you again and again, we need to keep in account the previous part as well. So we'll be talking about this, and we will be talking about this. So it is 7 by 8 into 5 by 15 and 1 by 8 into 6 by 15. 7 by 8 into 5 by 15 plus 1 by 8 into 6 by 15. And now you can simplify this. Very well done, Zahib. Excellent. The answer is going to be 6 by 41. This is going to be the answer. Yes. Any doubts with this question? Anything that you guys were not able to understand? Ishal, Munja, and Zahib.
Okay, thank you.
All right. Okay. Very good. And what about you, Ishal? Okay. All right. Perfect. So we are done with conditional probability. Now we will talk about binomial distribution. So I'll stop sharing this and I'll again switch to my whiteboard. Okay. Now, so far we have discussed simple probability, conditional probability, but for these, we were basically we had simple scenarios that you were tossing a coin or you were rolling a dice, or let's say you had a box and you were taking out a ball and stuff like that. Okay. Now we have different probability distributions. Okay. We will be talking about binomial distribution, normal distribution, geometric distribution, and stuff like that. For now, we will talk about binomial distribution only. Okay. So you would have a question. By reading the question, I'll talk about some conditions. By matching those conditions, you will see if it is a question from binomial distribution. If it is from normal, it would be most probably given. And we'll talk about all the distributions in detail. For now, let's talk about some conditions which we have in binomial distribution. So let's say you were able to spot those conditions, and now you know that this is a binomial distribution. Okay, so I'll tell you a formula for finding out probability in binomial distribution. We'll be using that formula and we would be able to find it out directly. The only thing I want you guys to understand is that this is different. Okay, this is not the simple probability we are doing every time, because you will find the wordings different as well. Okay, so let's talk about the conditions first. We are talking about binomial distribution. And when we say binomial distribution, we have a few conditions, and using those we will see if it is a binomial distribution question, if it's a simple question, or if it is some other distribution. Okay. Conditions. Number one, the experiment would be repeated multiple times. Repeated experiment. This is the first one. Then the second one is we would have fixed outcomes. For example, if you are rolling a die, you are either getting 1, 2, 3, 4, 5, or 6. If you are tossing a coin, you are either getting heads or tails. So the outcomes are fixed. Okay, this is what I wanted to tell you in this case. Then the third one is we will be talking about success and failure. So if the question says find the probability of getting 6 after rolling a die, would be 1 by 6, and that is the probability of success. The probability of failure would be not getting 6. Okay, so I've told you earlier as well, we do 1 minus probability of getting 6, and that would give me the probability of not getting 6. So for success, we use the alphabet P, and for failure, we use the alphabet Q. And always remember, please remember that Q is equal to 1 minus P, or P is equal to 1 minus Q. Okay, whatever it is, if you have failure, you can find success. If you have success, you can find failure. All right. And then the last one is the total number of times you are repeating the experiment. This was N. The probability of success and the probability of failure, they are going to stay same. Okay, so these are the 4 conditions which we need to take in account before thinking or before solving any question which looks like it is not a simple probability question. If that question has all of these things, it would be a question of binomial distribution. Okay, now if you know that it is a binomial distribution, why were we exactly spending this much time in knowing if it would be binomial distribution or whatever? because the formula is different for binomial distribution. Okay. So let's say probability. Okay, now I'll give you an example. Please understand this. Let's say you were rolling a dice 3 times and you are finding the probability that how many times you would get a 6 on that. Okay, now this is a different scenario. This is not simple probability that what would be the probability of getting 6. You are repeating the experiment, you have success and failure, you have fixed outcomes, and what exactly we are finding? The number of times you will get 6 on it. Okay, so that is basically R. I'm just writing down the formula and I'll explain that in detail. Do not worry. It is NCR P power R Q power N minus R. Please be very careful. This is not your binomial expansion formula. So we are writing, oh, wait a second. Let me write down Q into P then. So Q is coming first, P is coming here. So yeah, it is N minus R and it is R. Okay, just so you guys do not get confused. Okay, now let me add a few things. This is the success thing. You'll see it would be different in all the questions. This is the desired. Number of times we are wanting success. And then N is the number of times we are repeating the experiment. P is the probability of success. Q is the probability of failure. And R is basically, R would depend on the question. Okay, I'll write down a question and then you would understand what exactly is happening. Okay, so let's talk about the question quickly, just so things are clear. This is everything you should know about binomial distribution, and that is it. Okay, the question says a dice is rolled 7 times. X is a random variable for number of times that dice lands on multiple of 3. Let me write down the question first, then I'll explain it to you. Do not worry, please. The first part says find the probability that the dice falls on multiple of 3 exactly twice. Okay, let's understand the question. So forget about everything. Let's start reading the question. It says a dice is rolled 7 times. X is a random variable for number of times that dice lands on multiple of 3. So multiple, when they're saying multiple of 3, in case of a dice, how many numbers are multiples of 3? Yes. So we can have 3, we can have 6, so 2 only, right? So it could be that 2 sides are in favor of this. Find the probability that the dice falls on multiple of 3 exactly twice. Now, this is a very different question compared to what we do usually. Usually, we are not solving such questions. So, this is the time for you guys to think about all these conditions. That it seems that it is not a simple probability. So, let's see if it is binomial distribution. For normal distribution, it would be given, and we'll talk about all the other later on. Okay. So the experiment is repeated. Yes, the experiment is repeated. Okay, so it is that the first condition is true. Fixed outcomes, yes, we are rolling a dice, so it could be that we are getting 1, 2, 3, 4, 5, 6. That is also correct. The probability of success and failure is same. What would be the probability of success? So they are talking about this. X is a random variable for number of times that the dice lands on multiple of 3. This would be success. If the dice is landing on multiple of 3, that would be success. And this probability is going to be what? In total, we have 6 sides and 2 sides are favoring this outcome. So it would be 2 by 6. So probability of success is 2 by 6, and failure is, how do we find failure? 1 minus p, so it is going to be 4 by 6. Okay, and then the last one is n, p and q should stay same. Yes, nothing is changing. N is same, p is same, and q is same. So this means this question is a question from binomial distribution. How do we solve this? Find the probability that the dice falls on multiple of 3 exactly twice. So you need to find the probability that x, that is the number of times the dice lands on multiple of 3, is exactly twice. Okay, that is why I'm using equals to 2. In some cases, you will see that we would be using inequalities here as well. But this time around, it says exactly twice. So I've just used this 2. Okay. And now this is going to be what? Okay. Now I need to find this out. So it's very easy. Everything is there. N is the number of times experiment is repeated. So 7C R, that is my 2. 7C2 Q, that would be 2 by 3. So 2 by 3 to the power n minus r, that would be 7 minus 2 into p. This is p, 1 by 3. So it would be 1 by 3 to the power r, that is 2. And now I'm going to simplify this. And the answer is going to be 0.307. You can just find this out. And this is what we are going to get. Okay, I repeat. This was a different question. As soon as we understood this, that it is different, we started talking about the conditions. The conditions match. So this was a question from binomial distribution. And this is what we had to find. And this is how we do it. Any doubts with the first part? Please confirm that.
No, ma'am.
All right. Okay. Yes, Shalin Munja, is that okay?
That's fine, ma'am. Thank you.
Okay, welcome. All right, perfect. Let's talk about the second part quickly. So let's say this time around the question was, find the probability that dice falls on multiple of 3 once. Again, we are just to write it down and we can easily find it out. Probability that x, which was number of times, and x is going to be, find the probability that dice falls on multiple of 3 once. So what would be this? X equals to 1. Okay, this is what we are to calculate this time around. And again, the working would be same. NCR would be 7C1, Q is 2 by 3, N minus R would be 6, and P is 1 by 3, so that would be power 1. And once you simplify this, you are going to get 0.2048. Okay, now this time around, initially we had twice, now we had once, so that is why we are using once, okay? But the questions are not going to be of this type only. Now I'm erasing this. The question could be that you are to find the probability that dice falls on multiple of 3 at least 5 times. At least 5 times. Now this is where we will be talking about the inequality. So just pay attention. Probability of x. X is the number of times. This number of times should be at least 5 times. It means that x should be 5 or more, but it should be at least 5. So x is greater than or equal to 5. This is what you are to calculate. So this would include that you are getting it 5 times plus you are getting it 6 times plus you are getting it 7 times. But obviously you cannot get it 8 times when you are rolling the die 7 times only. So you are rolling the die 7 times and you are interested to get a multiple of 3. That is either 3 or 6. The question says find the probability that the dice falls on multiple of 3 at least 5 times. This is the only thing which you need to understand. When it says at least, it would be at least 5 or more. So this would have this plus this plus this. Now how to find this? We know that already. This is the simple case, simplest in fact. We can just do it directly. So it would be 7C5, then 1 by 2 by 3 power 2 and then 1 by 3 power 5 plus 7C6 2 by 3 power 1 1 by 3 power 6 plus 7C7 2 by 3 power 0 and then 1 by 3 power 7, and you will simplify this and that is going to give you the answer. All right, okay. So we can simplify this, but yes, the idea is clear that whenever the statement is at least 5 times and stuff like that, this is how you are going to do it. Please tell me if you have understood this sign or not. If you have 1% doubt, you can ask me again. I would not mind repeating it once again. Yes. What about you, Zahib and Munja? Is that okay?
Yes, ma'am. Thank you.
All right. Zahib, any doubts?
No, ma'am.
All right. Perfect. And then the last part says, find the probability that dice falls on multiple of 3 at most 2 times. So it is at most twice or 2 times. Okay. Now again, it would be probability of x. At most means that the maximum number should be 2. So x is going to be
Less than or equal to.
very good. Less than equal to 2. Now this means that we will be talking about probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. Now plugging in these values in the formula and all that part, that is not difficult, but the basic idea is this. Yes, is that okay? Yes, Munja, Ishal and Zahib.
Yes, ma'am. Thank you.
Okay, and then the last, this is last. If it says at least once, okay. In the beginning, it was once only. It says at least once. Now, at least once would mean probability of x greater than and equal to 1. So it would be probability of 1 plus probability of 2, like x equal 1, x equal 2. Yeah, Zahib, that is 0.3781. So just check if that fraction is same or not, okay? Right, so this is basically x equals 1 plus probability of x equals 2 plus probability of x equals 3 and so on till 7. But this would be a long method of doing it, okay? Yes, you can do it this way as well. But for this part, you can also do it this way, that you find the probability of x less than 1 and then we do 1 minus this, okay? So 1 minus probability of x less than 1 would give you this as well. So less than 1 means 1 minus probability of x equals less than 1 means it would be equal to 0, and that is it. So this would be much easier, okay? So I'll just wind it up quickly. All you need to understand is this was not a simple scenario, it was complicated. You will apply the conditions, everything is clear, you know how to apply the formula. This is something which we need to understand, okay? When it says exactly 1, exactly 2, simple cases. At most, in that case, it would be that maximum number should be whatever the number is given. At least would mean that minimum is this. But if it is at least 1, and if we start doing for this would take a lot of time. At least 1 would be probability of x equal 1, 2, 3, 4, 5, 6, 7. That would be time taking. So instead of doing that, always remember we can use this rule. If this is to be asked and if this is easier to find, you can do 1 minus this. And probability of x less than 1 is just probability of x equals 0. We can easily find this. So 1 minus this would give you the answer. Any doubts with this? Please confirm this, because tomorrow we'll directly talk about the past paper question.
No, ma'am.
Okay, and what about you, Munja?
I'm okay. Thank you, ma'am.
All right, so I'll stop sharing the screen. I'll stop the recording.